Welcome to Creation Radio and TV. I'm your host, Mike Riddle, and I am the founder and president of Creation Training Initiative. And what we do at Creation Training Initiative, or CTI, is develop courses that people can attend to learn how to defend their faith on biblical creation and apologetics. Now today we have a very special guest with us, Dr. Danny Faulkner, and you'd like to be called Professor. Tell us a little bit something about yourself there, Danny.
Okay, I received my Ph.D. in Astronomy from Indiana University. And for many years, I was on the faculty of University of South Carolina, Lancaster, where I taught astronomy and physics. At the end of 2012, I retired. They gave me the title of Distinguished Professor Emeritus.
But you haven't really retired, have you?
No, I haven't, because I retired early from the university so that I could take a position with Answers in Genesis. I started in January of 2013. And right now, it's been about 9 months on the job, and I've had a blast. I'm very happy here.
Well, good. Now, some of the things you did as a professor at South Carolina, what kind of courses did you teach?
I taught introductory astronomy classes. It was a regional campus. We serviced general education students for the most part. I usually taught each year, though, a 2-semester course, calculus-based physics, primarily for engineering and physics majors. During the summers, I taught the other physics class primarily for everybody else, the pre-med, pre-pharmacy, and so forth. And that was my teaching responsibilities mostly there.
But you did more than just being a professor there.
Oh, sure. Yeah, I've been involved in a lot of research over the years. I did a master's thesis before going to Indiana at Clemson University studying eclipsing binary stars. These are two stars orbiting each other, so they eclipse one another. And we learned a lot about stars that way. And I worked with one of the preeminent experts in the field there. And later on, last 15 years, I've been working with Ron Samick, someone who also worked for the same person I did. And we've been doing eclipsing binary research, going to various observatories, mostly in Arizona and South America, to do that work.
So you're not just book learned, you have a lot of hands-on experience.
Oh yeah, it's important, I think, as a scientist to stay involved in the field. And I frequently go to astronomy meetings where I present my results. So I'm doing work not only in creation science stuff, but I also do in the conventional astronomy stuff as well.
Now, you've also written a book on cosmology. What do you mean by cosmology?
Okay,
How's that different from astronomy?
Or cosmetology.
Yeah.
Cosmology is a study of the structure of the universe, and some people want to put on in that the history of the universe as well, the origin of the universe. And so I wrote this book about 10 years ago. It filled a void, I think, in the creation literature. And in that book, I give the history of man's ideas about the universe, going back to the ancient Greeks to modern times. And you probably know the big theory for a long time has been the Big Bang theory, at least going back about 45 years now. It's been the dominant theory back to the mid-60s. And so I traced it up to that, and I give my assessment of the Big Bang theory, and is it biblical? It isn't. And talk about all sorts of aspects dealing with cosmology as we know it today.
That's a big issue, the Big Bang, because I know an awful lot of Christian leaders out there who are trying to insert the Big Bang into the Bible. They say God used the Big Bang.
Yep.
Well, what does the Big Bang actually imply when we try and put it into the Bible?
The Big Bang theory is this idea that nothing existed. And when I say nothing, I mean not just no matter, no energy, but also space and time did not exist. Now, that's a really hard concept. Now, I do believe in Genesis 1:1, where it says, in the beginning God created heaven and earth. It's talking about the beginning of time and space as well. So I agree with the Big Bang people up to that point. But we start to swerve in different directions very quickly. They believe that suddenly matter, energy, space, and time came into existence about 13.8 billion years ago. And it came into existence expanding rapidly, and it's been expanding over nearly 14 billion years since then. It started a very ultra-dense, ultra-hot state, and from that it's cooled down to what we have today. And the sun formed about 4.5, 5 billion years ago, along with the Earth and other planets. And right away there are problems here, because biblical creation says that, for Genesis 1, says the Earth came before stars and the sun did. But this theory would say that many stars came before the Earth. Also, it would say that 9 billion years elapsed before the Earth came along, and that's not found in Genesis either. Plus the order of things found, when light appeared, when plants appeared, when certain types of animals appeared. The Big Bang is basically the cosmological evolutionary idea. We have geological evolution, we have biological evolution. Many times Christians realize the conflict in biology and geology. They're kind of asleep at the switch, though, when it comes to the conflict with cosmic evolution, which the Big Bang is that model today.
Well, I hope you're going to hold on here because very seldom do we have the opportunity to have an expert in our field, specifically in the area of cosmology and astronomy. So we're going to work Dr. Faulkner over here and get the truth about this thing called the Big Bang and see if we can have some people out there understand this. And I think Dr. Faulkner can explain it so we can understand it. So when you're confronted with this thing called the Big Bang, you will also have the answers. Now, Dr. Faulkner, did the Big Bang, a lot of people talk about like a dynamite explosion. That's not really what the Big Bang was.
No, that's not what the Big Bang is at all. The name Big Bang was coined, I think, in the late 40s or early 50s by the late Sir Fred Hoyle. He was an astronomer who believed in what we call the steady state model, that the universe has always existed and always will. It's the ultimate atheistic theory. So he believed the universe had no beginning and no end. And once in a radio show he was doing where they were discussing this, the BBC, he was exasperated and said, well, the universe didn't begin in some big bang. He liked the alliteration there. And people said, hey, that's a neat title. And Sky and Telescope magazine, even about 15 years or more ago, sponsored a contest where they tried to come up with a better name because they realized this name is really not a good name, but they failed. They couldn't find a better one. Just the alliteration's good, but it's most unfortunate because it gets across this idea as it was an explosion, and that leads people astray because that's not what it is at all. It's just the sudden appearance of space, matter, energy, and time.
Now, in the textbooks, they talk about Big Bang as a fact. They call it Big Bang theory, but they're really teaching it as a fact. And they talk about some of the evidences they give for this Big Bang. Now, has the Big Bang undergone any stages of evolution itself? Has it changed?
Oh, yeah. I frequently compare the Big Bang model of today than what it was 30 years ago. The Big Bang is a very flexible rubber model, if you will, a very elastic model because they can change it at will. It's got a number of free parameters, and they've dressed it up a lot over the years. But I'll just give a rundown of a few things that have happened in my adult lifetime, my professional lifetime. First of all, the expansion rates changed. They used to think it was expanding at one rate. Now they think it's expanding faster, and that changed the age. For many years, they said it was the universe began 16 to 18 billion years ago, or 18 to 20. Today they say it's 13.8 plus or minus 1%. So those two ranges don't overlap, obviously, so they both can't be right.
Okay.
Let's see. They had a couple of problems called the horizon problem and the flatness problem. They're kind of technical. We may not have time to talk about that today. But those were issues in the 70s probably and into the 80s. And so in the early 1980s, a guy named Alan Guth suggested this thing called inflation to solve those problems. The idea is like 10 to the minus 30-something seconds after the Big Bang began, which is a real short time interval, the universe went through a hyper expansion. It began expanding far faster than the speed of light, many orders of magnitude faster.
So it's not just some Christians who think the speed of light may have changed. It's the evolutionists
well,
also.
No, not so much the speed of light. It's the expansion of the universe exceeded the speed of light tremendously, which is okay. You can do that in general relativity, believe it or not.
Okay.
But they call this hyper expansion inflation. The world rapidly got much bigger. The universe did very quickly. And this is a nifty way to solve the flatness and horizon problem. Again, 30 years ago, it was just being talked about. Today, everybody agrees that seems to be what happened. There's no evidence for it, but that's what happened.
Did it slow down?
No, it went back to its original expansion rate. It starts off expanding, hyper expands in inflation, then very quickly settles down to the regular expansion beyond that. Another thing that happened is about 1999 or so, they had several lines of evidence suggesting that the rate of expansion's been changing. It's speeding up. And this is as if the space itself repels itself, driving it faster, the expansion. And this was something proposed by Albert Einstein 95 years ago. It was kind of done away with. People didn't like it. He called it the cosmological constant. Today they've rechristened it dark energy. There's a difference between it. It's a time-varying thing, and Einstein's idea was not a time-varying. And this is something that's taken the world by storm. And again, 30, even 15 years ago, you didn't include this in your Big Bang cosmology, now you wouldn't think of not including it. Dark matter is another one they've thrown in.
I was going to ask you, is there a difference between dark matter and dark energy?
Not really. I mean, there is a difference really between the two of them. Dark matter is something else, and there's evidence for dark matter apart from any cosmological ideas. But once you have that, it's a free parameter you can play with. So you can adjust the amount of dark matter to fit your models to the data.
Now, can we see it or taste this dark matter?
No, but we can detect its effect by gravity.
Okay.
It turns out in groups of galaxies and rotations of galaxies. I think there's pretty good evidence that dark matter exists, but unfortunately, now it's invoked to explain away problems and solve problems in the Big Bang theory. A string theory is this idea of how particles work. It goes far beyond below even protons, electrons, and neutrons. It's explaining the basic structure
And those
of particles.
three things are, okay, I was going to say, those are the three main parts of an atom.
Today, yeah,
Yes.
but they believe that those particles maybe consist of 6 extra dimensions of things vibrating.
Now, you
with
said
little
they
strings.
think.
Yeah,
is there any
this
observational evidence
no, not
to
yet.
support this?
There are many people in particle physics that study the elementary particles of the universe who believe this best explains how matter today works. There's not yet any evidence for it, but it's a pretty good theory, and they're working on making some predictions and testing those eventually. Not yet.
So it's really an unverified hypothesis at this point.
At this point, a very well-developed one. It's in particle physics, though, but in the early universe, with the high temperatures and densities that you'd have in the Big Bang model, you better factor in string theory to make your models very realistic with the high densities and temperatures there. So this is something that wasn't put in models 30 years ago. Now you wouldn't dream of not putting them in.
So the Big Bang is constantly changing because they keep finding new things.
They keep adding additional factors in.
So it almost makes it non-falsifiable. In other words, there's nothing there that can falsify it
That's
because
the
they
problem.
keep changing.
Yeah.
It's like
And
Jell-O.
It's like Jell-O. As soon as a new problem comes along, new observation. This happened many, many times. You simply hypothesize a new field, a new force, a new factor, and that saves your bacon each time. It's becoming a rescuing device. Now, Mike, this kind of reminds me of what was called the Ptolemaic model. Back almost 2,000 years ago, around 140 AD, a man named Claudius Ptolemy, living in Alexandria, Egypt. He was Greek, living in the Roman era, however. He wrote a fantastic book about dealing with astronomy called he called the Syntaxis. Today we call it the Almagest. But it had a lot of neat things about the history of astronomy, but the thing it was really known for and what preserved it for the next 2,000 years was the fact that it had a very good model of predicting planetary positions. The stars remain fixed with respect to one another. The stars change throughout the night due to our rotation, and from season to season due to our revolution around the sun. I look today at the constellation Orion, and I see it pretty much the way Job did when he was mentioned probably 4,000 years ago, maybe the oldest book in the Bible. Looks the same because the stars, though they're moving, they're so far away, they don't change. But superimposing that backdrop of the fixed stars, the motion of the sun as we orbit the sun each year, the motion of the moon as it orbits us each month, and then you get the 5 naked-eye planets, Mercury, Venus, Mars, Jupiter, and Saturn. They look like bright stars, and they have this erratic motion back and forth through the stars. And Ptolemy was trying to explain that motion. And the way he explained it was a series of circles on circles called epicycles. Which you have as the Earth somewhere near the middle. A planet like Mars would go around like this, but superimposed in the circle here, this deferent, we had a little epicycle going like this. So as Mars went around, it went through this very complex motion. And it worked very well to explain planetary motions. And so for the next 15 centuries, people used this theory. The problem was occasionally it didn't quite fit reality. Observations were out of sync with it. So what they did is they just threw in extra epicycles. They had another epicycle going this way and going this way.
Kind of like what they're doing with the Big Bang.
Yeah, adding something new each time. And it got to the point in the late Middle Ages, early modern times, some systems had as many as up 100 epicycles to make the system work. And this is the most successful theory in the history of science. 15 centuries. Nothing else comes close. Its beauty and its strength was that you could always adjust it and modify it in order to make it fit new observations. However, it was its undoing because if a theory that can explain anything and everything cannot be falsified, and according to Sir Karl Popper, that's not science if you can't falsify it. And I think the Big Bang has come the same way. It's gotten to the point you can't falsify the theory because no matter what new observation you have, you can always alter it.
And by falsify, you mean there has to be something out there that could show this
Potentially.
is wrong.
Potentially. You could do an experiment and say, if we do this experiment and it proves to be wrong, it contradicts what our theory, then therefore the theory is falsified. But so far you can't do that, primarily because you're free to change it at will.
It's very similar to the fossil record in the evolutionists.
Yeah.
We don't find all the transitions, but they have an answer for that. Sometimes in past, it happened so fast, it didn't have enough time to leave the transitions. Therefore, if we find the fossils, it shows evolution. If we don't find the fossils, it shows evolution.
Yes, that's it.
It
Same
can't
sort
be
of comparison.
falsified.
Yeah,
Yes.
that's the same sort of idea going on with the Big Bang. And I'm not the only one saying this. There are secular scientists, they're atheists, by the way, who say, is the Big Bang even true? You know, can you really prove that it's true or prove that it's false? And so a lot of people out there asking questions, and I think at some point it will collapse under its own weight, just as the Ptolemaic model once did.
But until then, they keep teaching it as a fact, even though it was never observed.
Yep.
And it hadn't been repeated, so
Right.
it's really not a fact.
And sometimes you read textbooks and see stories about this, or read coffee table books about it, and they offer a whole slew of different evidences. But there's really only one evidence for the Big Bang, one test that's ever survived, and that was what we call the background radiation. This is predicted by George Gamow as early as 1948. The idea is a few 100,000 years after the Big Bang, there was a period of time when the universe was still pretty hot and gas was ionized and stars hadn't formed yet, but once it cooled down to a point, all the gas formed in stable atoms for the first time. There weren't any ions, and the universe became transparent for the first time. And radiation from that era is streaking out now through this space, no longer is blocking its way because the universe is no longer opaque. And after billions of years, we should be able to see this. It's a prediction he made back in 1948. And he realized it would have been redshifted due to the expansion of the universe. So instead of being around 3,000 Kelvin, which in real temperature is 5,000 or 6,000 degrees Fahrenheit, it should be only about, a few Kelvin, which is really, really, really cold, hundreds of degrees below zero.
We're talking close to absolute zero.
Yeah.
For no movement.
And in 1948, the technology did not exist to measure that, but 15 years later it was. A couple of astronomers named Arno Penzias and Robert Wilson stumbled across it in 1964, published it in 1965, and it was considered the confirmation of the Big Bang model, because the other model you see at the time was a steady state that Sir Fred Hoyle liked, and that one couldn't predict it. He went to his grave in 2001, all those years in between, trying to find a way to make the steady state theory predict that, and he couldn't. So if you want to ask me, is there any evidence for the Big Bang? Yeah, that's the one evidence it has, but there are some problems with it. And that's some of the things they've tried to explain. The horizon problem, for instance, comes out in this. There are other things in the background radiation which are problems for the study for the Big Bang theory, and so that's the one, but they always try to snow you on other things. Like they say, well, the Big Bang predicts the universe is expanding. Well, so did the steady state theory. And in fact, it was known prior to the Big Bang model. The Big Bang model was concocted to explain that. So that's no prediction. They also try to say that the various abundances of the light elements, such as lithium, hydrogen, and helium, is predicted by the model. But they had that data in hand before they made the prediction. And if tomorrow we decided we had the lithium abundance wrong, they would go back and change the model. One of those parameters are like 8 or 10 free parameters. That's another one to get the model to fix. So I'm not impressed with those kind of predictions. They're actually not predictions at all.
On one side, it's like jello, but we also have to understand when we're talking about science, sometimes scientists do make mistakes and they correct them in all honest manner, because we're always discovering new things.
But when you're really invested in a model like this, it's very difficult to think outside the box. And that's why it takes a real mugging by reality to get you changed. And that, revolutions in science don't happen easily.
We can see that in the history of medicine too. We're in a lot of trouble.
Oh, yeah.
Now, if I gave you the question, if you could just tell our audience just 5 simple things that really are a problem for the Big Bang that people could understand.
Okay, I don't think inflation really solves the problem of what's called the horizon flatness problem. The background radiation is supposed to be very smooth, and it is, same temperature everywhere, but they would predict in the model that you had to have slight variations in density in the early universe. This gives us structure. You need little slightly more dense regions and less dense regions. And if it's a little more dense in some places, it acts as a gravitational seed to attract more matter, and that gives us structure such as galaxies, stars, planets, and people. So we're here to see it.
So you're saying we're stardust?
Well, no, sort of, yeah. It's a long roundabout way to get there, but according to the theory, that's sort of it. But you need these little density enhancements, more dense and less dense in different places, and that should show up as temperature fluctuations in the background radiation. Well, they made the predictions back in the 70s, what they would expect. And they launched this thing in 1989, the COBE experiment, COBE, to look for the predicted fluctuations in temperature. See those density fluctuations that show up as temperature fluctuations. 2-year mission, 1991, they released the data, and it was perfectly smooth. They couldn't find the fluctuations. It wasn't until they did some high-powered statistics they found fluctuations order of magnitude, factor of 10 lower than they expected. And it later was confirmed by other missions. That's not a problem. But the problem is that the model predicted fluctuations of a certain level. They found them a factor of 10 lower than that. Temperature fluctuations in 1 part in 100,000, not 1 part in 10,000 as predicted. Now they say that the data and the predictions perfectly match. Well, how does that happen? Well, because they changed the model once again to fit that.
There's our jello.
I have a long memory. I remember. Don't snow me and tell me that they beautifully matched because they didn't.
Now, are these kind of things taught in the classes in schools? These
Yeah.
problems?
Oh yeah. Well, not the problems. They snow people for the most part. Of course, when I taught, I certainly talked about those problems. Another problem is, where did the Big Bang come from? Well, there's a guy, name was Tryon, back around 40 years ago, opined that the universe is just one of those things that happens from time to time. That despite what you might know about the conservation of energy, for instance, the universe just popped into existence. And they tried to explain this in terms of quantum fluctuations and all sorts of high-powered physics and so forth. But it's a snow job once again. Yeah. There is no explanation. It just happens.
So I remember the old saying, from nothing, nothing comes.
Nothing comes. That's an old ancient Greek idea. They said it in Latin, as it turns out.
Yes.
But yeah, the idea that the nothingness begets nothingness, and people are writing serious books about this, all sorts of fanciful things, that there's a multiverse and all sorts of crazy ideas, very speculative, no science really in it, a lot of philosophy, and not particularly good philosophy. So why the universe is here rather than nothing is another real big problem I think you have.
And then if it's going to pop into existence, where did the space come from to pop into existence?
It just happened.
Just happened. Okay.
Yeah, it just happened. And to me, that's amazing that normally very smart, rational people can hypothesize that, because in reality, it's much easier to believe that a God external to the universe, transcendent the universe, created the universe. And I think ultimately the problem, Mike, is that it's not a head problem, it's a heart problem. If you believe that the God made everything around us, including us, then maybe you might expect that Creator would have some expectations or demands upon your life and upon your behavior and your attitude. And I think people are in rebellion against God. They don't want to be subject to Him. They don't want to bend the knee to Him. And that's what the real problem is here. They'll believe in the irrational simply because they don't want to subject themselves to the authority of God.
What problems did the Big Bang have if you try and put it in the Bible? How does it affect our understanding of the Bible and the gospel?
Massive problems. First of all, the age issue comes into play. I do believe the Bible very clearly says that creation was accomplished in 6 days. Even if you want to believe long periods of time, we've got the earth on day one, at the very beginning. It's a very Johnny-come-lately, as I said, 9 billion years in between. But you have a problem there. You have stars that have to exist in the first billion years or so. At least 8 billion years before the Earth existed, and so you've got a real problem. How come stars were made on day 4?
So we have a logic problem there, law of non-contradiction, so to speak.
And the order's wrong, the date's all wrong, and this kind of morphs eventually into ideas of cosmic evolution on the scale of how stars form and planets and so forth, and it goes into the classic problems, it melds into the classic problems of the ordering geologically and biologically on the Earth.
Now, has anybody actually ever seen a star form?
No.
No.
You hear news reports frequently. Just had one a couple of weeks ago. What we see are snapshots of what people think young stars may look like.
There's that word "think" again.
Yeah, they assume that they're interpreting in terms of what they want to see.
Yes.
And I'm not saying that it isn't a star being born, but I am saying that you can't see it born. For one thing, the process takes way, way, way too long. It'd take many human lifetimes. We've only been watching a few years, so consequently, you can't see the process anyway. But so it's a series of snapshots that people have put together to interpret in terms of how stars are born.
Yes, because I like it when it says in the Bible on day 4, and he made the stars also.
What's even worse than that, if you look at the Hebrew, it simply literally says the stars also.
Yes.
They have to insert "and he made." The stars are kind of an afterthought, and I'm a stellar astronomer. I study stars, and that's kind of frustrating to me because the Lord spends a lot of time worrying about the sun and the moon, and almost an afterthought everything else,
Isn't that
including the
amazing?
stars.
And we have quadrillions of stars out there.
Yeah.
And it was so easy for him to make.
Oh yeah.
In one day,
In one day, and name them all and counts them.
we
and
have
it's
a pretty
amazing.
mighty God.
Yes, he is.
Now, how does it affect the gospel? If we're implying, the Big Bang implies billions of years. How does that affect the gospel?
Well, you've got problems eventually with sin before fall.
Oh,
If the curse, the sin is what brings death into the world, and yet if you believe in billions of years, you have to believe that death preceded Adam. And that's a problem. It's a real problem. And then you have to deal with Adam and Eve. Were they real? Were they just some sort of story? If so, then you have a problem because Jesus is called the last Adam. In contrast, through his disobedience, sin entered the world, and death by sin, and through the obedience of one man, Jesus, the last Adam, all can be made alive. You've got a real salvation issue there.
so that undermines the entire foundation for
I
the
think
gospel,
so.
the Big Bang cosmology.
Ultimately, it does. Yes.
So all these theologians out there, they're putting it in, did they really know what they're doing with the Bible?
Yeah, no, they aren't. And there have been many attempts in the past to interpret the Genesis in terms of cosmology. I could talk about the rakia, which is translated firmament, in the King James. Unfortunately, we're running out of time. That's another concept we could talk about, but it's a prime example of interpreting Genesis in terms of the current cosmology back over 2,000 years ago. It goes back to the Septuagint.
Well, Dr. Martin, you're a wealth of information here. You've got the Big Bang, you understand stars and where they form or not, galaxies, comets, that's another thing you've written on.
Yeah.
And now, would you want to come back at some point in time?
Absolutely,
We'd
yeah.
love to have you back. We've been listening to Dr. Danny Faulkner, who works for Answers in Genesis right now, was a professor at South Carolina University. And he's going to come back and explain more about things like, what about the comets? Are they a problem for the Big Bang cosmology? And many other areas out there that our youth are being taught as a fact to support the Big Bang. If these lessons had been a blessing to you, you might consider financially supporting the Ministry of Creation Training Initiative. You can do this by going to our website, creationtraining.org. Again, that's creationtraining.org. Your tax-deductible donation of just $20, $50 or more a month, or a one-time gift of any amount will make you an education partner in building an army of Christian educators who can teach the biblical account of creation and train others to be able to defend their faith and be biblically faithful to God's Word as it states in 1 Peter 3:15. But sanctify the Lord God in your hearts, and be ready always to give an answer to every man that asketh you a reason of the hope that is in you, with meekness and fear.